Today our first speaker will be Cesar Cordero from the Office of Water. He will be talking about available technologies for the treatment and control of Legionella. And following Cesar will be Mark Rogers from the Office of Research and Development, and he will be talking about water quality in large buildings. So with that, I would like to turn it over to Cesar.
Hi. I don't know, I just want to confirm that everybody is able to hear me. Good afternoon, everyone. So today I would like to provide you all with I guess some information on our current knowledge about treatment technologies regarding Legionella, or for the control of Legionella. As some of you may be aware, EPA is currently in the process of developing a draft document to compile state of science information about some of the treatment technologies that are commonly used or known to be commonly used to control Legionella. And I will also be sharing with you our approach to compile this information and also present an overview of the information we have compiled so far. Next slide. So why are we undertaking this effort? So as many of you may be aware, the trends in Legionellosis infections as well as outbreaks continue to make headlines in the news and are also a major focus of federal agencies as well as state health programs because of the Legionellosis infections that have been seen recently. So this increased attention has resulted in the installation of different treatment technologies as a protective measure against Legionella. And this has resulted in questions from both states and also affected institutions or facilities about the efficacy of the treatment technologies as well as any potential water quality impacts that may result from the use of some of these treatment technologies. So in an effort to try to address some of these questions that we have been getting, EPA formed a multi-agency task force back in January of 2014, and we started putting together a draft document where we tried to summarize the available peer-reviewed literature related to treatment technologies that are being used to control Legionella, particularly in the building water systems. So the development of the document was a collaborative effort which included experts from different parts of the Environmental Protection Agency, including regional offices and also headquarters offices, including the Office of Research and Development, and also Mark Rogers was one of the participants from ORD, which will be presenting afterwards. Also, the group included state representatives and also individuals from the Centers of Disease Control and Prevention, and the different individuals involved contributed both as authors and or reviewers during the development of the document. There was a diverse group of expertise and experts involved in the development of the document, which included expertises such as epidemiologists, microbiologists, public health experts, engineers, and others. The document includes peer-reviewed literature published through August of 2014, and right now the document is undergoing internal review from our management, and once we publish the draft document, we anticipate that there will be opportunities for public review and to provide input on the draft document. And following that public input period, the document will also be reviewed by an external group of independent experts. So in the next several slides, I will provide you with sort of a general overview of some of the topics and the technologies that we covered throughout the draft document. Then to start, I will provide some information or some background on Legionella, and the background includes an overview of the bacterium's physiology, ecology, and the epidemiology, and other relevant characteristics. So to start, Legionella was first described and named in 1976, and this was following an outbreak at an American Legion convention in Pennsylvania. As many of you may be aware, the genus is composed of over 50 species, and many of which are considered to have the potential to cause infection under the appropriate conditions. So Legionella are ubiquitous aquatic organisms that have been found in water distribution systems as well as in premise plumbing. And when premise plumbing refers to plumbing system inside private buildings such as homes or hotels, hospitals, and similar structures. So three important characteristics of Legionella that are mentioned in the document and which may be critical to their survival in this type of engineered water systems are their ability to colonize biofilms, also their ability to parasitize protozoa, and their tolerance of warmer temperatures. So the infections caused by Legionella are generally known or called legionellosis, and this can occur in two different forms. One, the first one is a more severe pneumonia-like infection known as Legionnaire's disease, and the second type is a milder flu-like disease known or called Pontiac fever. So infection with Legionella occurs primarily through inhalation or aspiration of the organisms in water droplets, and some of the potential exposure routes that we have seen in the literature include shower heads, hot tubs, decorative fountains, respiratory therapy devices, among other potential exposure routes. It is also important to note that Legionella is a major player in waterborne disease outbreaks, particularly those within building water systems, and this has been shown by CDC data between 2009 and 2010. The bulk of the document currently focuses on preventative and remediation strategies, but we also cover multi-barrier approaches such as the hazard analysis and critical control point and water safety plan type of I guess barrier approaches. So these multi-barrier approaches are usually implemented to proactively reduce the risk from Legionella and other microbial and physical risks that may be associated with building water systems. So they're not limited to Legionella control. In the document, we also currently present several case studies that demonstrate the effectiveness of this type of multi-barrier approaches to control the growth of not only Legionella, as I said previously, but other pathogens in building water systems. Now, for each of the remediation strategies or treatment technologies included in the document, we provide a description of the technology. We also go over a little bit of the general history of the technology, a characterization of its effectiveness, which includes laboratory, pilot, and full-scale studies, or a description of these studies. Also, some of the potential impacts on water quality and general operation considerations with regards to each of the treatment technologies. Several points to note regarding specific about chlorination and other treatment technologies are that though the results that showed effectiveness or overall effectiveness, this effectiveness varied on a case-by-case basis, and a wide range of chlorine doses were used, and studies were conducted under varying quality water quality conditions, which may explain the variability between or from study to study, or the results showed from studies to studies. So maintaining a disinfectant residual in the water distribution system was important, but not only for chlorine, but for most of the chemical-based treatment technologies that I'll be talking about later on. It was also observed that an increase in chlorination effectiveness as temperature increased, and several studies highlighted the potential protection of Legionella when it was incorporated into biofilms or inside protozoa. And this, again, was something that was also observed for many, if not all, of the other chemical treatments. Some of the potential water quality issues observed in the literature or reported in the literature that may result when chlorination is used are the occurrence of disinfection byproducts, also the potential for taste and odor changes, and also corrosion of the piping system or the components of the piping system within the building. So similarly to chlorination, again, the studies that evaluated the effectiveness of chloramination showed a wide range of inactivation effectiveness. And again, this depended a lot on the specific water conditions and other experimental conditions that were used in the different studies that we considered. Again, an increase in disinfection efficacy was also noted with increased temperature for monochloramines, and something that was particular to monochloramine was that there were studies that showed an increased effectiveness in penetrating biofilms when compared to chlorine specifically. Some of the potential water quality issues that were observed associated with chloramination or monochloramination include formation of DVPs, as well as also nitrification and corrosion. Chlorine dioxide was shown to be effective at relatively low doses, and also at penetrating biofilms and inactivating Legionella inside amoeba by some of the studies. Also, there were studies that provided success stories where chlorine dioxide was used in a hospital water system setting. Similarly to chlorine and chloramine. Chlorine dioxide also showed increased effectiveness with increasing water temperatures, and some of the potential water quality issues that were observed when using chlorine dioxide included the formation of disinfection byproducts, again, also taste and odor reports, and also the potential for corrosion of the piping system or its components. Now moving on to copper-silver ionization, there were multiple studies that show that copper-silver ionization was effective at reducing the cultivability of Legionella when applied at particular copper and silver ion concentrations. There were also several publications that reported a successful application of copper-silver ionization in building water systems, particularly in a hospital setting environment. Some of the studies also showed that protection of Legionella inside amoeba or in biofilms could reduce or could potentially reduce the effectiveness of this treatment, as was the case for some of the previously mentioned treatment technologies. In addition, some studies reported that some Legionella strains appeared to be capable of developing resistance to copper-silver. With regard to potential water quality impacts related to copper-silver, some of these include corrosion, and high copper concentrations could also result in odor and taste issues. So with regards to ultraviolet disinfection or UV disinfection, there were several studies that show that low doses of UV light were effective at decreasing or reducing, and in some cases even eliminating Legionella from a building water system. It is also important, I guess, to note that some of the studies show that UV treatment is only effective on the water that passes through the treatment device, and that when it is installed on an old building water system where Legionella may already be present, then supplemental treatment would be required to deal with the issue. Though there are no chemical substances released into the building water, and then that means that there are no disinfection byproducts produced by this technology, it was noted that the effectiveness of this type of treatment can be negatively impacted by the presence of iron, manganese, calcium, and magnesium in the water, which can affect the lamps leaves, and thus reducing the effectiveness of this type of treatment. Another of the non-chemical based treatment options that we're covering in the document that was reviewed was the point of use filtration, which was shown to be effective in removing Legionella in several case studies, though the effectiveness would be dependent on the filter pore size of the unit that is used. I want to note that depth filtration was shown to be ineffective in some of the studies that we're looking at in removing Legionella, including media that incorporated silver as part of the filtration unit. Some of the concerns that we saw reported in the literature when using this type of technology included the potential for the clogging of the filters, and this would this could result in an increased risk from high levels of pathogens being released into the system if not maintained or replaced appropriately as per manufacturer instructions. So we also, in the document, we also discuss some treatments that are most commonly used under emergency circumstances, such as an ongoing outbreak. And these emergency disinfection technologies or processes are meant to be used temporarily rather than on an ongoing basis, as many of the previously described technologies are usually applied. And the water or the treated water during emergency disinfection is not meant for consumption. So one of these emergency practices is superheating and flushing, which involves increasing the water temperature between 71 and 77 degrees while the outlets are flushed at least for 30 minutes. This process was, or the literature that we looked at showed that this process was effective in hospital outbreak scenarios, though regrowth is pointed out as one of the potential concerns when using superheat and flush, unless it is followed by continuous supplemental disinfection. Hyperchlorination involves the injection of high chlorine concentrations for a determined contact time period, and the literature shows mixed results with the success of this approach for controlling Legionella. And a potential reason for the mixed results could be, or some of the reported potential reasons could be the protection of Legionella within amoeba. Now, as you may expect, addition of almost any of the treatment technologies that I have described before to a building water system will likely result in changes to the water chemistry or the microbial composition within the building water system, water or biofilms. Thus, I guess it's important that if you are considering installing any of these treatments in your facility, you should consult with your primacy agency so they can provide you with more detailed information on any applicable requirements. So here in the second bullet, as you can see, there are some links where you can go to find out who the appropriate primacy agency is, or you can also contact your EPA regional office, and they may be able to further assist you in finding out who the appropriate contact would be to get information on any specific requirements that may apply to your facility if you're considering adding treatment. Also, I guess also important, if you are a technology developer or manufacturer, I don't know if there are any on the line today, but if there are any, and you're looking for information on how to get your technology approved to be used for treatment, you can consult EPA's Water Supply Guidance 90, for which the link is also provided in the third bullet of the slide. And this guidance provides recommendations to the states or primacy agencies on how to approve alternative drinking water treatment technologies. And this could give you a sense of what type of information states may, or primacy agencies may be looking for to approve any new or alternative technologies for treating drinking water. And finally, I guess I want to provide you with some of the next steps on where we're going with developing of this document. Currently, the draft document is undergoing internal review, and we anticipate to be publishing the draft document this coming summer. The draft document availability will be announced via a Federal Register notice, which will also provide details on how to provide public input. Public input will likely include a public listening session that will allow for both in-person and remote participation via webinar. And our current plan is to hold the listening session shortly after the draft document is published this coming summer. So after we consider the public input we get from you all and other interested stakeholders, we will have the document reviewed by an independent external group of experts, which should be happening later this summer or maybe early fall. And if everything moves according to plan, we are expecting to publish the final document by late fall of this year. And with that, I conclude my presentation. Thank you.
Okay, thank you, Cesar. Okay, I just want to remind everyone, especially for those who may have joined a couple of minutes late, we do ask if you can, we did have a poll, and if you do have more than one person in your room, if you could just type in the number of people in your room with you in the question box so we can keep track of that. Okay, and also, I know this question comes up a lot, and I forgot to mention, we will distribute the slides to everyone via email by the end of this week. Okay, and with that, I'm going to turn it over to Mark Rogers with the Office of Research and Development.
Okay, thank you, Michelle. On a second, let me just get my screen shared.
Okay, you're good to go, Mark.
Okay. All right. Sorry. Let me just. Okay. Well, thank you, Cesar. That was a great introduction and a great coverage of the treatment options. The first few slides here, I'm going to go through quickly because I'm just reiterating what Cesar already explained to us. So, you know, as he said, you know, the problem with infections in hospitals is not a new thing, right? So the problem with water quality in building or premise plumbing systems, you know, and the sensitivity to especially hospital-acquired infections, you know, has been and just will continue to be seen as a public health problem that really needs a solution. Again, Cesar talked about the CDC outbreak data that you know, the latest data you know, indicating that Legionella, that particular pathogen is responsible for most of the drinking water outbreaks that have occurred in the last several years, and that the most common deficiency identified in that report was premise plumbing. And and while there were really few deaths in the 2009-2010 time period due to waterborne outbreaks, all but one of them were due to Legionella. And this does not include, of course, the thousands of other cases of legionellosis that occur in our nation associated with these outbreaks. And it also, does not capture other waterborne disease from other environmental pathogens like mycobacterium and pseudomonads. And so, I think the question before us is really, can we avoid this disease by better management of the water quality in our large public buildings? So again, Cesar has already gone over talked about Legionella, about the ecology of this. So, we do a great job of reducing risk from fecal pathogens in drinking water. But the water delivered to customers is not meant to be, completely free of all bacteria, and the distribution system and premise plumbing systems have their own, naturally occurring microorganisms. Really, we can, divide up sort of bacterial pathogens in sort of two categories. Those that are sort of unable to grow in the environment, ones that you might be familiar, E. coli, Salmonella, tend not to grow, although there are some cases perhaps, but in general, they just don't amplify in environmental conditions. Whereas there are other pathogens like Mycobacterium and Legionella that are able to grow in the environment. Again, Cesar talked a little bit about the ecology of Legionella. This is just a slide just sort of showing that these pathogens like Legionella and Mycobacterium and others have these characteristics that make them well adapted to living in these premise plumbing environments. And one of these adaptations is that they're able to survive inside of these phagocytic cells. So in the human body, they survive and amplify within cells called macrophages. And sort of the analogous cell in a premise plumbing environment, in a biofilm environment, are these free-living amoeba. And so these amoeba will ingest the microorganisms like Legionella, Mycobacterium, but these organisms are able to sort of evade the the host defense there, and they're able to amplify where they can be then released from these cells and then are carried downstream in water systems to infect other cells or to infect humans that are ingesting that water. And so these organisms can occur, like you see, as like these trophozoites, but they can also occur as these environmentally resistant cyst forms. And so within these forms, as Cesar said, they can help protect the pathogen from disinfection. And so our predictive models, will say that based on the number of these amoeba in the water, based on the predicted amplification of Legionella within amoeba, based on the size of the particles that are released by the macrophage, and based on what we know about the human physiology and the fact that these particles have to be small enough to be respirable particles because there's a respiratory infection, that Legionella pneumophila densities of 10 to the 6 to 10 to the 8 colony-forming units per liter, would be would really be required for infection, and that's based on certain uncertainties, of course, but levels of this magnitude are not uncommon in drinking water environments. Oh, sorry, gosh, sorry. Sorry. Okay. All right. So this is just a slide just to point out that I stole from a colleague here. It's just every building is a dead end, right? So water is treated and is produced and is pumped through a distribution system where the water quality changes, even if it's piped to your home or to a hospital or to a hotel. And then even once it gets in the building, there's a variety of pipe materials that can affect the water quality, but the chemistry and the microbiology, variety of plumbing configurations, and a variety of water use patterns. And all of these combine to sort of create the conditions that are going to exist in any premise plumbing. So I just want to take a few minutes just to go over sort of the applicable EPA regulations. Because our current regulations really do play a role in how we deal with these pathogens. And I think what's relevant to remind the audience today is that the Safe Drinking Water Act really defines public water systems as in terms of how many people are you serving water to, right? So 15 service connections, or if you serve an average of 25 people per day, for various lengths of time. You know, if you provide water to those people, that makes you a public water system. And then there's different categories of that, of course: community, non-community, transient, non-transient. But of course, most customers and connections are not a public water systems, right? But if you, as a customer, you know, sell the water past the meter connection, or if you provide additional treatment, and that's really what we're talking about today, then you can be viewed by, you know, by the regulatory agency as a public water system, and that then calls into play compliance to the applicable drinking water regulations, monitoring requirements for such rules as the total coliform rule and the lead and copper rule. And so I like this quote that I got off of Cesar's an earlier presentation that he gave, where he said that you know, providing drinking water is not the primary function of many small public water systems, and that's been our experience here, certainly, and largely they just often don't have the expertise. They may have a licensed operator. I mean, lots of things that are needed to really produce and deliver safe water. So here are some just those premise plumbing treatment options that Cesar went over. I won't go over them again. He did a good job of explaining, you know, the aspects of them, sort of the pros and the cons. I will say that you know, the one thing that's not explicitly explained in the Safe Drinking Water Act, as I understand it, is what constitutes treatment. So if you treat the water, then you have to comply, you know, with the regulations. But actually, what constitutes treatment isn't well explained. And so some agencies are going to, well, if you change the chemical composition of the water in any way, then that would constitute treatment. But even then, that's, you know, it's debatable, and you know, what kind of data is there, you know, for some of these treatments actually, you know, change the chemical composition. So there's pros and cons to each of these. As Cesar said, there are unintended consequences for most of these. And what I just wanted to show here is that, you know, free chlorine, monochlorine, chlorine dioxide, these are recognized treatments under the Safe Drinking Water Act. So if you're gonna employ these, then you know, then you're gonna fall underneath the regulations. Copper silver ionization is not mentioned in the Safe Drinking Water Act, but it is being viewed as certainly as treatment. And then ultraviolet light and point of use filtration are just two other ones that people have employed. And what I just want to point out here is that in addition to all the things that Cesar mentioned about these treatments, the important thing to me is that the first four provide some sort of residual disinfectant, you know, that can remain as a barrier to contamination throughout your system, while ultraviolet light and point of use filtration do not. So we've been working with two local hospitals that chose to install copper silver ionization systems, and these systems can be plugged in, can be plumbed into either the hot water loop, hot water lines, or it can be used in both the hot and the cold. And it's a pretty simple system. The water just flows through the cell across these bars that have the copper and silver metals, and electric current is generated that goes across the gap, and then the copper and silver ions that are formed are released into the water. And the ionic form of copper and silver, the actual forms, depend on many chemical characteristics of the water. So the pH is important, but other chemical constituents of the water can affect the effectiveness of these, like phosphates and chlorides. So one of, you know, in addition to all of the other many issues, right, that you'll have to deal with if you want to install additional treatment into your building. You know, you're also going to want to determine whether the treatment that you're applying is effective against the hazards that you've identified. And you know, often my understanding is that, you know, the effectiveness of the treatment itself, if you're looking to control Legionella, is often not a requirement of the regulatory agency. But if you're paying the money and going to the trouble to put all this in, you're going to want to understand how effective it is. So among the many issues, right, you're going to have to figure out where are you going to sample in your building, and what type of sample are you going to take, and what are you going to monitor for, and then, you know, what are the best methods, you know, for monitoring for the pathogens. So this idea about representative sampling, I mean, you really need to think about in your particular building, if you have multiple buildings, if you have multi-floors, many water outlets, different types of outlets, you're going to have to decide which ones of those you're going to sample. And then you have lots of choices about how to sample. So whether you take biofilm swabs or bulk water samples, whether you look at faucets versus shower heads or both, whether you do first draw water samples versus letting the water run for a while, flushed water samples is important, and of course hot versus cold. So this is sort of a schematic of one of the local hospitals that we're working on, and of course the recommendations vary quite a bit for sampling plans. But so some things to really consider, sort of the sampling location. So you want to know where you're sampling with regard to the entry point of the water, the treated water coming into the premise. You're going to want to include all buildings if you have multiple buildings, and you're going to want to look for areas of concern, especially in healthcare facilities. And so these areas concerned in this particular hospital were in the intensive care unit and surgical suite. You're going to have to decide, what are you going to monitor for? So, if you want to look at the control measures that are in place, and in this hospital, they had it's a free chlorine system, and they have hot water temperature. So we wanted to measure the hot water temperature, and so they're also employing, of course, the copper silver ionization, and then we also we're interested in looking at the microbiological parameters, and so we've been looking at the heterotrophic plate count bacteria, and we've been looking at Legionella and mycobacterium. So we have looked at we have taken data on hot water, so the maximum hot water temperature in 2 locations. One that was near the boiler, and then also another site that was on the other side of the campus. We looked at free chlorine levels in the cold water after a 2-minute flush, and we looked at copper silver levels using ICP analysis in the hot water, and we measured those in both the first draw sample and a 1-minute flush. And then we also looked for the various bacterial parameters in faucet swabs and in large volume hot water samples. And so the first thing here is so this hospital employs sort of a conventional recirculation loop for its hot water, and you'll see guidelines of they really would like to see 140 degrees Fahrenheit, which is 60 degrees C, entering the loop, and then 124 degrees Fahrenheit on the return. So we can see that Legionella in this little red box, Legionella sort of the optimum sort of growth conditions for this organism is 24 to 46 degrees C. As you can see, the hot water in this building is so the average is sort of right in that meaning. So it's the hot water going in is pretty good, but certainly on the other side of the campus, the hot water is well within this growth range for Legionella, and this is not taking into account the loss of heat from pipes that run from the loop to the taps. And there's also often recommendations for the maximum length of those pipes, knowing that you get heat loss there. There's always a concern about scalding when you have elderly patients, and so there's anti-scald devices and mixing valves available to help guard against scalding. And but there's really no good consensus sort of on the best use of these devices. Where's the best place to place them? But I'd like to make the point here that that maintaining a hot water temperature, right, that's out of the growth range of Legionella is really one of your best defenses against the colonization of this particular organism. Just showing the free chlorine in this hospital was pretty good going in, and near the entry point, and they were able to maintain a pretty good free chlorine residual even on the other side of the campus. This is just some data looking at the copper and silver levels, and this data is the sort of a compilation of data over the first 2 years of them installing this system. The graph itself is some data from the hospital staff, and this is showing that it's really kind of in the 3 sites that they were looking at, the copper levels as they measured them spiked quite a bit. The limits for copper in water, the actual limit is 1.3 parts per million, and for silver there's a secondary MCL of 1 part per million. And so with this copper silver ionization systems, the recommended range is really sort of what's indicated here, about 0.3 to 0.8 parts per million of copper and 20 to 40 parts per billion for silver. So the data in the green box kind of shows that taking a first draw and a flush doesn't give you significantly different picture of the metal ion concentrations, but we see a wide range of values, and some of them, and some of the higher numbers certainly take the hospital out of the limits set. I just want to say just a word about bacterial monitoring for these organisms, especially Legionella. So you can use culture methods, which are going to give you culturable counts. So those would be called viable, but really people want to it's best to just call them culturable counts, right? So these are organisms that are able to grow in the lab, and but we know that organisms can be injured, or maybe you don't provide exactly the right culture conditions, and so they're not going to grow for you. Or they could be what people describe as in a viable state but not culturable. And so people are doing your micro testing for you. You really need to ask them how they're giving you those results. There are molecular methods that are also available. So these molecular methods detect parts of cells, so they're not actually maybe detecting the whole cell, and they would detect live cells. They're both viable and culturable cells, but also dead cells. So you have to understand what methods you're using and make sure you understand what the limitations are. So here's just some data, just for the microbiology from this hospital. So we looked at Legionella pneumophila. We were able to culture them out of the faucet biofilm samples before the copper ionization treatment was installed. It wasn't the heavily colonized building by any stretch, but we did see some. But after they turned the system on, going back to the same taps over and over again, we were never able to culture the Legionella again. But again, it's hard to know. really, we can't say right now with any certainty that they weren't there, but maybe they were just in this viable but non-culturable state. And we also looked at heterotrophic plate count bacteria, and we found lots of Mycobacterium intracellulare organisms, but we just didn't see any significant impact on the levels, the occurrence of these other organisms by the copper-silver system. I just want to give real quick. I just wanted to show you some data from sort of an unrelated but really very nice EPA study where they looked at 68 taps from around the U.S. and they were each tap was sampled 4 times over a 2-year period, and the results show that of the 68, 32 taps were positive at least once, but of those 21 taps were only positive once. So the point here is that it's really important that you understand the frequency at which you're going to do your sampling, and to understand how you interpret a positive and any one positive or negative result. So we're looking at another hospital also in a local hospital, and so we're looking at the water quality and the occurrence of Legionella and other bacteria. And this is a hospital that's a much larger hospital. It has 2 patient buildings where patient rooms are, and these are 8-floor towers. And this is the sampling plan. It's a little different. We're looking at faucet swabs or we're looking at water samples, from 10 different faucets, and we're also collecting shower hoses. And these are a sample that we decided to collect here because we felt it would be a good source of biofilm material. And there's a little picture here of a man, who's an employee of the hospital, that has to escort us around and often has to go into the patient rooms and take the samples for us. And this is just the idea that it's an interesting aspect of working in a working hospital where you really have to be careful, that the sample collector itself doesn't become a source of pathogens. So again, just some data from that. So if we look at free chlorine levels in this hospital and first draw cold water samples, we can see that it's really a wide range. And while over the average there's always a residual in these samples, there were many times when there was no measurable chlorine residual at all. In the hot water, as you expect, the free chlorine dissipates quickly, and so there's really very little chlorine residual protecting that hot water. If you look at the temperature range in these 2 buildings, you can see that all of the first draw hot water samples are really down in that range where the growth of Legionella would be allowed. And then finally, when we looked at these biofilm samples for Legionella pneumophilus here, group 1 by qPCR, out of 60 samples, 60 shower hoses, we only found 9 of them that were positive. And all of this data has been collected really before they have turned the system on just recently. So we'll be continuing this work and hoping to continue to document the effectiveness of the copper silver and other water quality management practices here. Just a few quick ending slides here, just to say that we're also interested in the microbial community of these premise plumbing systems. So, as I mentioned before, Legionella and Mycobacterium exist, as a member of a larger microbial community, right? And so we can anticipate that the composition of the overall community, the diversity of and the proportion of microorganisms there, play a role in whether the environment is more or less conducive for the growth and survival of all environmental pathogens. So here's just some representative data on how the microbial composition changes in one hospital, the the last hospital that I described, when we look at hot water samples from different parts of the building. And so, understanding how the community varies naturally will allow us to better identify, changes when they occur as we continue to study this hospital. And then, in addition, these buildings that are using heavy metal ions as a disinfectant, we're interested in what other changes might occur as a result of long-term exposure of the community to these metal ions. So, for example, could a tolerance for these metal ions develop in the bacterial community? And could this tolerance extend to other antimicrobial agents, such as clinically relevant antibiotics? So we know from the early data that antibiotic-resistant genes are present in the bacterial community here, and so we'll be looking to see if the presence of those or if additional genes occur. Okay, and then the last slide I have is just some bench studies that we're doing. We've just started with Legionella, looking at challenging them with the copper and silver hospital water. So this is water that's been dosed, and we're bringing it back, and we're bringing our lab, and we're challenging the Legionella. And right now we're just doing pure culture work. We're just looking so we can document that the copper silver ions have an effect on the culturability of our Legionella cultures. We are holding them. We're neutralizing the metals, holding the cultures. We don't see any evidence of resuscitation. Our plans are to add some additional measures of viability. We'll look at membrane integrity. We'll look at messenger RNA transcription, and also resuscitation in amoeba. Okay, so I think that's about the time I have. Maybe I have time for the last closing slide. So again, the summary is just expect water quality to change throughout a large building. Okay, it's going to happen. Many options exist if you want to add additional treatment. But really what you need to do is prepare a good plan, right, for managing these risks. You need to assemble a good team of people that have responsibilities in various aspects of building management, maintenance, infection control. Understand the water systems in your building. Know how the water flows. Identify the hazards you want to control, and then identify how you plan to control those hazards. Where will the controls be applied, and what limits will you allow? How will you monitor for these controls? And then decide how you're going to validate the effectiveness of these controls. Okay, there's my disclosure saying that everything I said has been reviewed, but nobody's going to own it but me. And thanks for your attention. And
okay,
here's the last slide. Thank you.
Thanks, Mark. And we apologize for running over a little bit, but we want to make sure we got all that information to you. This is an important topic. So I know that some people probably have to jump off the webinar now, but we will stay for a while to answer questions. We do have quite a few questions here. So we will do our best to get to as many as possible. As you can see on your screen, we do have the schedule up for the rest of the year for the Small Systems webinars. And at the bottom, there is a link to the schedule of upcoming webinars and also the recordings from our past webinars. You will receive this in an email, so you'll have that link for a later time. Okay, so what I'm going to go ahead and start with Cesar in the Office of Water. We will ask him a few questions, and then we'll switch to Mark and kind of go back and forth a little bit here. So, okay, Cesar, to start, is there a study that compares the effectiveness of chlorine at various temperatures or vice versa, holding the temperature constant and varying the chlorine concentration?
Yes, hi. So we have several studies that do compare the effectiveness of chlorine at various temperatures, and also another variable that is evaluated in the studies is pH. I would have to go back to the specific study, because as I mentioned when I was going over the presentation, the different sections in the document were written by different individuals. So I would have to go back to the specific studies to find out about the details on whether the temperature, the holding the temperature constant and varying the chlorine concentrations was a specific, I mean, how that was specifically addressed in those studies. But I can definitely comment to or answer that, yes, the different chlorine concentrations were evaluated at different temperatures and at different pH levels.
Okay, Cesar, we have another one for you. Does reducing the total organic carbon by GAC assist in keeping the Legionella population at low population density?
That one, even though this is not something that is specifically addressed in the document, I mean, my personal response would be that I would assume that yes, that reducing TOC would have an impact in the Legionella population and potentially other bacterial populations as well. So that would be my personal answer. I don't know if Mark, I don't know if you have anything to add to that question.
No, it's good.
Okay.
Okay, we have a few more here for you, Cesar. How common is a filter failure?
Again, this is something that will vary depending on the user. I mean, there's a lot of different filters that can be used out there, and I think it would greatly vary depending on the user and how the user follows the manufacturer instructions or recommendations. How common they are, that's not something that we go into or that we evaluate in the document, but again, it will depend on the individual users.
Okay, has a program of regular cleaning of shower heads and other fittings been evaluated?
Well, evaluating or a program of regular cleaning of shower heads and other fittings is not an independent treatment process itself, so it hasn't been evaluated independently. This is something that I see that could be part of a multi-barrier approach, such as a hazard program or a water safety plan.
Okay, Cesar, I'm going to give you one more question before we move to Mark for some questions. This is in regards to the document. What is the title going to be, and who will the experts be on the external peer review?
Okay. Yeah, the title of the document or of the draft document right now is the title of the presentation. So Legionella, current knowledge of treatment technologies is what we have as the title of the document as of today. Again, this is a draft document, and there may still be changes to it. In terms of who will be on the external peer review, the peer review is meant to be an independent peer review from us, so we don't know who's going to be in that expert panel. We anticipate that it's going to be three experts in the panel, and these are going to be chosen by whoever the contractor is that will be facilitating the external independent peer review. So we don't know. The answer is we don't know who the experts will be, and they will not be chosen by EPA.
Okay, thank you, Cesar. Okay, we're going to go ahead and move to Mark Rogers now for some questions. Okay, Mark, here's your first question. Why cases of Legionella, sorry about that, my questions keep moving, let me do here. Do you have any data on potential Legionella growth under systems that may be using water heaters as needed or heated at the point time of use?
Data on
potential Legionella growth under systems that may be using water heaters.
Well, certainly. So it's point of use water. So rather as opposed to water heaters like the tank heaters. So No, I'm not aware. I suspect that there is data. I don't have that information. I know that the group at Virginia Tech, Mark Edwards' group, has done a lot of work on looking at the risk of Legionellosis and the growth and survival of those organisms in various water heater configurations. And I know that they've addressed. I know that they look at both tank heaters with gas-fired versus electric heaters, and there are differences there, and also the sort of the on-demand electric heater. So I would encourage you to go to the literature and look for some information from Mark Edwards' group.
Okay. Is there any current regulations or government recommendations on water sampling requirement for Legionella in hospitals or public buildings?
No, I don't think there are any government current regulations or government recommendations on that. I think that would be difficult to prescribe. Every building is going to be different, and so I think that you need to be mindful of looking at sort of what you can see as might be representative sampling. So one sample is probably not going to do it. So you want to do a good coverage. Some agencies are coming out with guidelines or saying they sort of based on a healthcare facility based on the number of beds, you might do 4 or 6 or 10, and then you have to decide on the frequency of that. So will you do that quarterly? I see quarterly is being recommended a lot. I don't know if that's really necessary. Other hospitals I know do it annually, but that's really recommendation for looking for Legionella. I think the point of my presentation hopefully was that you would want to look for more easily measured control measures, things that they're easily measured, like your disinfectant residual, like your hot water temperature, and get a good handle on that aspect.
Okay. Is Legionella more likely to be inhaled or ingested?
Oh, well, that's a good question. I think that inhalation is really how I think the models are sort of based on that. So you inhale these. I think that's the word. But certainly, but there's also aspect of aspiration, and so sort of the difference there. But I don't believe it's it's an organism that you ingest and it causes sickness that way. It's really a respiratory pathogen.
Okay, so I don't know if you need to go back in your slides for this or not, but for hospitals 1 and 2, were there any Legionnaire's disease cases associated with these hospitals?
So no, there wasn't. So both of these hospitals made the decision to employ additional treatment just based on their desire to just, according to them, just to provide the safest environment for their patients. So no, to my knowledge, there's been no documented outbreaks of Legionellosis at these 2 facilities. Okay.
Do you identify biofilms as well? And the second part to that is, does the type of biofilm affect the presence of pathogens?
Well, so identifying biofilm, do we identify the biofilms? Well, we have some, right. So we are collecting data, and we are analyzing the samples, looking for some identification of the bacterial species that are contained within these biofilms. Right now, we're just collecting the data. I think there's some intriguing observations that people have made that pathogens can be associated with biofilms that are growing on certain kinds of surfaces, right? So the biofilms. So for instance, you might find Legionella. You might find it occurring more often in maybe copper pipes versus PVC, and so And so we would expect the bacterial composition to be different between the biofilms on those two surfaces. So there's some intriguing observations there, but I'm not in possession of any data that points to if we know what the community composition is, we could predict whether or not you would have Legionella colonization.
Okay. What is the most commonly used culture methods for mycobacteria?
Okay. Well, I wish my colleagues were here. You know, Middlebrook agar is the name of, and then there's a Lowenstein Jensen media. So we use Middlebrook here, and it seems to work pretty good. You know, culturing mycobacterium out of the environmental samples is a real chore. We have an expert lab here that does that, and they work very hard to to push the background organisms down enough to let those slow-growing mycobacterium push through.
Okay. Are copper-silver ion units considered treatment, and what would make the water system regulated?
So I think that, this is a question that is being answered by the various states and the various regulatory agencies at the state level, and they're answering that question in a different way. So some states, I know that the state of Ohio, where we are, if they know of a building that's employing copper-silver ionization, then they will consider that as providing additional treatment, and they will view that as a public water system, and they will impose the requirements of the Safe Drinking Water Act. So you have to have an operator of record, and they have to do compliance monitoring. So I know what happens, but I believe there are perhaps other states where that is not exactly true, right? Where the state agencies either aren't aware of systems in, or they have decided that that there's not enough information right now to determine whether or not they should regulate them.
Okay. Next question: what incubation time should be recommended for HPC?
Right. So HPCs, those counts that anybody gives you are really based on the method that they use. So that's a good question. I'm glad people are thinking about that. We use R2A agar, which is a low nutrient agar, and we incubate them for 7 days at 25 degrees.
Okay. Does Legionella live in a polymicrobial environment, or is it the exclusive microbe?
I think the general consensus is that Legionella really thrives in a polymicrobial environment, as you phrase that.
Okay. What reference are you? I'm not really sure what slide this is in reference.
No, I understand. Okay. Right. So there was a reference. Right. This is the reference about the infectious dose. Mm-hmm. So I was talking about this predictive model, the quantitative microbial risk assessment information, that I mentioned, and so I would refer the listener to some papers by Mary Schoen and Nick Ashbolt. They've done some nice work where they have run these models and collected information on the dose response and on other aspects of this interaction between Legionella and amoeba, and they're the ones that published that figure that I gave of 10 to the 6 to 10 to the 8 CFU per liter.
Okay. Does it make a difference what type of pipe is used as far as Legionella growth? That's
not something that we have collected data on here. I think that there's some data out there, perhaps more anecdotal observations than maybe real published data, but that perhaps. So anyway, so I probably shouldn't comment because I haven't read anything on that, so I don't know.
Okay, I'm actually going to allow Cesar to answer one question here really quick, and we'll get back to Mark. Cesar, this is a question for you. If a system has to be hyperchlorinated and is taken offline, is hyperchlorinated then flushed back to original chlorine level? How does this fit into EPA regulations?
I would have to refer the person who asked the questions or anyone else who had similar question to this my slide on my presentation, slide 14, and also I think Mark also touched upon this when he was addressing the question about whether or not copper silver is considered treatment. So anyone with this type of questions, they should refer back to their primacy agency. So in particular with the hyperchlorination question, primacy agencies may have different way of addressing this, and the primacy agencies are allowed to have stricter requirements that what EPA requires. So they should go back to their primacy agency for specific guidance or specific questions about regulatory requirements, which may be stricter than EPA requirements.
Okay. All right. Thank you, Cesar. We're going to go ahead and go back to Mark now for some questions. Why are cases of Legionellosis related to healthcare facilities, why are they increasing?
Yeah, so that's a good question, right? And so the writer also says, proposes that perhaps it's because healthcare providers are testing for it more. It's becoming more, that the doctors are looking for it. They know what to expect now. And I don't know. I think it might be some of that. This is really a pneumonia, so it can be caused by other microorganisms as well, probably similar symptoms, and so I'm sure that there has to be lab results to confirm this. I don't know. I think that it's possible that certainly in this age where we're trying to conserve water and our buildings, using less water means the water is going to flow more slowly throughout our buildings. That's going to increase that water age, they call it, and so water doesn't age well, and so the quality degrades and growth permissive conditions increase, and so it could be a combination of those.
Okay. Well, we have time for we're not going to be able to unfortunately get to everyone's questions. There are quite a few. So we'll go ahead and have Mark answer 3 more questions. You're okay with that? Okay, so Mark, are you sampling hospitals with monochloroamine disinfection?
We do have a project that we just started on another hospital that has elected to use a monochloroamine generating system, and this is a relatively new system available in the U.S. I don't think they have installed the system yet, or I don't think they have turned it on. But the plan is to install it into the hot water system, and so we have a project where we're helping them monitor the effectiveness of this treatment, also other like the nitrate and nitrite levels, and probably looking at nitrosamines. We're going to be looking for whether they experience nitrification episodes. And so, yes, we are looking at that.
Okay. Does Legionella develop resistance to high temperature thermal treatment?
I'm not aware of any data that says that Legionella develops tolerance to sort of the high temperatures, like 60 or 70 degrees C. That you might use in an emergency situation when you flush the lines, with the hot water. I can tell you. So I'm not aware of any tolerance, but I can tell you that I think everybody would agree that while that's effective, could be effective in a very short-term scenario. Often, almost every time, right? The Legionella recolonize, they come back. You probably don't kill them all. They grow, and then sometimes the levels afterwards are even higher than they were before. So it's really should be viewed as just an emergency treatment, and not perhaps, we should really think about whether that's a long-term management control.
Okay, and so this is related to your studies. In your premise plumbing treatment options for Legionella control, you missed temperature, proper temperature. Oh, you missed temperature. Why is this overlooked?
You know, that's a good question, and I tried to address that, and in fact I had a statement that I just didn't say, but right. So of the treatment options, all of these disinfectants that you add, right, but the proper maintenance of your hot water temperature and your cold water temperature, right? So you need to keep the cold water cold, you need to keep the hot water hot, and that's really, you know, that's I think an often overlooked management control for Legionella, and so I didn't mean to really leave that out, unless the writer is talking about the sort of a superheating treatment where you run, you know, very hot water through your lines for a period of time as a management control. I don't have a real experience with that, but my sense from the literature is that it's really just a very short-term fix.
Okay. We have time for one more question. Okay, Mark, do you have any information about the ease of implementation of secondary disinfectants and required maintenance?
Well, certainly that's a very important point, and so because, you know, the failures that we have seen of many of these treatment systems that people have used for Legionella control, and then down the line they get an outbreak. Oftentimes you look back and you can see how they mismanaged their treatment, how they didn't maintain it well. And so in that document that Office of Water is going to be releasing, we do talk for each of these treatment about what are the maintenance issues. And so, for instance, the copper-silver, relatively simple system, but the metal bars will actually scale up, and often so you have to remove them periodically and just rub them down, just remove the scale. It's not a difficult thing to do, but it's important to do. And then just, you know, monitoring the metal ions. So ease of operation, I think, is not something I can really speak to for all of them. But there certainly are issues with regard to corrosion. So high doses of chlorine often can give you, you know, corrosion problems. So you really need to monitor that well. And but certainly maintaining your system, maintaining this whatever system you choose, maintaining it is the most important point.
Okay. Thanks, Mark. And thank you all for joining us and staying on for the Q&A session. I know there are still a lot of good questions here that we couldn't get to. When we do send out the presentations to all of you, it will have Mark and Cesar's contact information, so you can contact them if you have additional questions. Okay, again, thank you for joining our webinar, and just so you know, next month, which I should have mentioned earlier, we're going to be talking about drinking water systems and cyanotoxins. So we hope you join us for that webinar as well, and thank you again.